Okay, so we have this situation. What I recommend you do first thing. You should get your breath. Value Y in dollars. Time in years. Okay. Then you put initial value $5,000. And then after 2 years, let's just say 2 is here. You go up to $6,000. Now, if that's 5,000, half of that would be 2,500. Half of that would be 1,250. So 1,000 would be about that much. So we'll say that Y equals 6,000 on this line. T equals 2 on this line. And I really do recommend that you go to the trouble to draw these dotted lines and label. So the question is, how long is it going to take this thing to double? Well, that's one of the questions. First, you want to find a model for the investment. Okay, so Y equals AB to the T. Y equals 5,000, T equals 0. So 5,000 equals A, B to the 0. So we get 6,000 equals AB squared. Okay. Well, we can write those two equations. We can write them over here. Okay. We'll call this equation 1. Call this equation 2. Equation 1 is 5,000 equals A, B, 0, which equals A times 1. So A equals 5,000. And it doesn't even involve the value of B. So from the first equation, we already know A equals 5,000. In the second equation, solve this equation, B is going to be the square root of 1.2. Now, I didn't go through the details of solving that, but the details should be obvious. You're trying to solve for B, so you divide both sides by 5,000. 5,000 into 6,000, the same as 5 divided into 6 is 1.2. So B squared is 1.2. that means that B is the square root of 1.2. Maybe more significant figures than we need, but I'll say 1.41. Okay, so what's our model? So from all this, we go over here. What equals 1.41 B to the T? Okay. So it's been a couple of weeks since any 2 points you have in that are either all above or all below the x-axis will give you an exponential model with an asymptote at the x-axis. Okay, so you got to be able to take 2 points in the plane and solve these 2 equations, which is pretty easy. Now, a lot of times you don't have the convenience of knowing what the initial value was, so you don't have a b to the 0. So you would have to solve this equation for A. If this was b to the 5th, you would have A equals 5,000 over b to the 5th. And you plug that in for A. Again, we did that a couple of weeks ago. Okay, I think we did it in here. In any case, it's one of the most fundamental things you do. If you got the information, you get the model. This is how you get the model if you got 2 points. Okay. The easiest model to do is A, B to the T, because you don't have to use any logarithms. If you try to do A equals A times 2 to the KT or A times E to the KT, you have to use logarithms. We get all our information here. Now, here's the model. Okay, so that's this part. And nobody really got it, but people made more or less a good start on it. Okay. And, I think somebody forgot to take a square root, so didn't quite get the right model. I think it didn't look that closely. Okay, so let's have you go on. Can you identify now the growth rate, the growth factor, and the doubling time? Okay. The fundamental properties of the exponential function. Well, one is it always has this model, or the model could be A e to the KT, or A times 2 to the KT. But this is the easy one to solve. You're going to use the simultaneous equations, as I said, because it doesn't involve the logarithm. Of course, I'm repeating that. But okay, so I wrote this down wrong, and I really apologize. Y equals A B to the T, right? A is 5,000. B is 1.41. That's raised to the T. So your model is Y equals 5,000 times 1.41 to the T. Pretty easily found if you think. Draw the graph, take the coordinates of the points, take the coordinates of each point, put them into this form, and then solve the simultaneous equations. Now we've got this. So I'll give you a minute, see if you can find the growth rate and the growth factor. Okay. Want to find the growth rate and growth factor. These things are fundamental. The growth rate is just the thing you're raising to the t power. And then the growth factor. Is here. And the growth factor is like the interest rate. Oh, heck. When I did this, okay. No excuse, I'm getting plenty of sleep. I don't know what's happening. 1.2. I gave you this. If you said the growth rate was 0.41 and the growth factor is 1.41, you'd be right. Okay. Now the square root of 1.2 is more like 1.09. So with that correction, what's the growth rate and what's the growth factor? Okay, I made a bunch of mental errors here. When I did the square root of 1.2, I did the square root of 2. Okay, because I was thinking doubling time. I was thinking ahead to doubling time. No excuse. You should have checked my answer, right? Because 1.41 to the second power doesn't give us 1.2. 1.09 to the second power actually gives us about 1.19. 1.10 gives us like 1.21. And so just approximated as 1.09. Okay. If you want to put that into your calculator and get a more accurate growth rate and growth factor, you can easily do it. Okay. So anyhow, if this is our model, now up here I said this was the growth rate and this was the growth factor, which is totally wrong. And I didn't notice that until somebody wrote it down that way. Okay. And that was my error, not yours. Okay. This is the growth factor, this is the growth rate, and this is like the interest rate. The growth factor is not an interest rate. The growth rate is the interest rate. Okay. If it's an investment of some kind. That's like a 9% interest rate. Make sense? Okay, now, we talked last time about, when you do homework, have a section in your notebook where you can write down important points. So you can quickly review for an exam and remind yourself of the things you understood. You almost certainly answered the question for growth factor and growth rate correctly because just about everybody did on the homework. Okay? But it was so easy, you just forgot it. Okay? So there are three things we need to understand about the exponential function. Okay? Again, investment initially worth $5,000. 2 years later, it's worth $6,000. You can display that as 2 points on a graph. I do recommend you draw these projection lines. Then find the y equals a to the bt model for this investment. You write y equals a b to the t. You've got an x and a y, or a t and a y here. You plug in that t, which is 0, and you plug in that y, which is 5,000, and you get an equation with two unknowns, a and b, or two unknown parameters, is what we would call it. Okay, then you have this point, which is 2, 6,000, t is 2, y is 6,000, and it helps to, do as I've done pretty consistently. Make sure we understand these. You can put numbers on the axis, that's fine. but it kind of clutters up the graph a lot of times. So it might not be the best way to label your scale. Okay, well, anyhow, this point then gives us y equals 6,000 and t equals 2. So 6,000 for y, 2 for t, we get this equation. We write down these two equations and we solve them. Okay, solve the equation. We'll generally solve the first equation for A or B, it doesn't matter. Okay, but usually we're going to solve for A because to solve for B, it's usually in power and you'd have to do a reciprocal power. Okay, no root. So it's probably best to solve the first equation for A, put that into the second equation and solve for B. Then if you don't already know what A is, if the power is not zero here, you got to put that value of B back here and solve for A. That's your typical procedure for solving simultaneous equations, okay? Well, once you have the model, you plug, we've got the full one there. Okay, you plug the values of A and B in to this form, and there's your model. And now this 1.09 is a growth factor, 1.41 is a growth rate. You do that process, you know something pretty significant, okay? Now there's one more thing, what's the doubling time? Well, you use T sub double, T double, is your doubling time. But how you double, so T equals T double. $5,000 value, will double. $10,000 when T goes from 0, where it's $5,000, to T double versus where it's double. But here's the equation you would solve to find the doubling time. Solve this equation, I recommend that you express it in logarithmic form. So change this equation to logarithmic form and find your solution. And the solution is going to be around 8. That was going to be around 8 years. But what you find it using the equation. Okay, now solve this. You have this equivalence and click the off screen. Okay, we have this equivalence. So we can put this into the form b to the a equals c, and then we can flip it over to the logarithmic, which we can solve just using the calculator. Fine. Why do we do that? We can't solve this for t dub as long as t dub is up here in the exponent. Okay, so we divide both sides by 5,000. And isolate 1.09 to the t dub should be obvious. We divide both sides by 5,000. Now we have this in the form b to the a equals c. When you're doing the first several of these equations, you're going to want to write out b equals 1.09, a equals t dub, c equals 2. So you know for sure that you're putting the right symbols into this form. But this then becomes log base 1.09 of 2 equals t dub. So that t dub equals log of 2 over log of 1.09. And you use your calculator and find that that's 8.04, if I believe the one correct calculation I think I saw. Okay. Now I want you to take a couple of minutes and make yourself notes on this process. What would you want to see in your notes if you're reviewing for an exam and you know you're probably going to see one of these things? Okay. So to give you about 2 or 3 minutes, just jot something down, something along the lines of what you might want to see in your notes. Now, I will tell you that what you want to see is not the details of this solution. That could be somewhere else in your notebook. I'd recommend you have a section in your notebook where you give yourself directions. Here's how you do this, and here's what it means. Without a bunch of symbols and a bunch of calculations. Okay, I did ask everybody to make the notes that they would make in preparation for final exam. Okay, notes they would want to see. Okay, first thing I would say is, if we know 2 points for an exponential model, okay, because you want to start knowing just what it is you're doing. If you start writing instructions without saying what they apply to, and we're just talking about, here's how you get an exponential model if you know 2 points. Okay, that's real specific. And you can say that in your own words. But you want to have that, you want to orient yourself. If you're reviewing for a final, you want to know what all these instructions are talking about. Okay, then the first step I use is I make a graph. Okay, anytime you have data for one of these functions, you want to do a graph. We'll put that data on a graph. Now you don't absolutely have to do that, but it helps you focus on what you need to do next, which is, okay, now plug the coordinates of each point into the model. Okay, coordinates of the first point go into the model, coordinates, the second point going to the model, and now you have two simultaneous equations with the two unknowns. Okay. Then you solve those equations. Okay. If the model is A, B to the T, then yes, you probably want to solve one of the equations for A and plug that into the other equation. Then you can solve that other equation for B, and you can plug that value back into the original equation to solve that one for A. Now, in the example we used here, you automatically got A because one of our points was the y-intercept. That's not generally going to be the case. Okay. Well, then you take your values of A and B and plug them into your model and write them into your general form, and there you've got your specific model. Then you identify the growth factor and the growth rate, and I still don't have that. How do you modify these things? In this case, that would be growth rate would be 0.09. Growth factor is 1.09. Then you have how to find this doubling time. What do? Well, you can take the value of A, which is going to be the value of the model when t equals 0, and then set your model equal to double that. It'll tell you how long it takes to double here to here. Now, that's a concept you're going to probably have to wrestle with just a little bit. It's not overly difficult, but it's not something that's likely to pop into your head and make sense first time you see a statement like this. You put it in your own words. In solving the equation, remember, if doubling time is in the exponents, you're going to have to change this to logarithmic form and solve it that way. Okay. So if you're interested in the way I would do it, you want to go to this part of the video, which is going to be reasonably close to the end, and see what you can do. Now, you have an assignment on logarithmic models that I have currently due on Friday or Saturday. Okay, 2-3 days from now. I'm going to probably delay or maybe even omit that assignment. Okay, because I want to move on to simultaneous equations. Especially we did this with these simultaneous equations. We want to look at simultaneous linear equations. Now we did this in chapter 2. But on the midterm, people did very, very poorly on that. Almost nobody got it. Okay, solving two simultaneous equations with two unknowns using elimination. And I'm convinced, because it's not that hard, I'm convinced just because you didn't think to review it. There's a lot of evidence that, things people pretty much knew how to do, they just hadn't reviewed for the final, which is one reason I'm advocating that you think through the process and make sure it works. Okay. So that when you want to review for the final, you have a nice, concise set of instructions of your own wording to review. Okay. If you find that you don't understand from your words, well, you learn something, you learn how to get better words. Okay, and then you can go research. You can look at your text, you can look at notes, whatever, and say, okay, I forgot I left out this step. Boy, I shouldn't have left that out. I didn't remember it when I saw it, but now I remember it. So let's just modify the notes a little bit. Maybe you want to make those notes double spaced, so you can insert things because nobody ever gets it right the first time. Okay. 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 There are 2 points in the graph. Right there is the form of the linear model that we're going to use when we do simultaneous equations by elimination. By the time we're done, you're going to see how to do this for any number of points. And the model could be an appropriate polynomial. Okay. The method we want to use is elimination, because elimination can be modeled by matrix equation. So it's very easy to solve. And there are all kinds of utilities that will solve matrix equations for you as well. Okay. So anyhow, we want to see what the matrix equation is and so forth. But first, we plug the coordinates to this point into the model. We plug the coordinates to this point into the model. Give us an equation 1 and an equation 2. Okay, you do that? Okay, you plug this coordinate in for x, you would get x is 4. So you'd have a times 4, which we'll write as 4a. And y is 3. And then you could get, that's b. Y is 3, so you have b times 3, which is 3b. The second point, you're going to get 9a plus 7b equals c. Okay? Now that's how you plug in 2 points into a model. Let's just say now that we have equations in 2 lines. Let's say this equation is four x plus 9y equals 8. The equation of this line is negative 3x minus 5y equals 12. Okay, now that's not an accurate graph. You know how to do an accurate graph and find the intercepts, the graph by the intercepts. So what we want to do is we want to solve the equation system 4x plus 9y equals 8, negative 3x minus 5y equals 12. And what do we do? What's the first step? Somebody want to tell me? Well, we don't have a lot of time. I'll review it for you. Okay. This is equation 1. This is equation 2. We can choose to get rid of x. We can write 3 times equation 1, 4 times equation 2, which means we multiply all the coefficients here, both sides, by 3. And on this equation, we multiply both sides by 4. Can you do that real quickly? Okay, some of you done some of it, some still thinking. 3 times, first equation means 3 times 4x plus 9y equals 8. That's going to give us 12x plus 27y equals 24, because 3 times 4 is 12, 3 times 9 is 27, 3 times 8 is 24. 4 times the second equation gives us negative 12x minus 20y equals 48. Now, if you remember the notation I've used before, we're going to do equation 1 plus equation 2. That doesn't mean this equation 1 plus this equation 2. After we get 2 equations, if I write an instruction here, it refers to the last set of equations, right? So this is our equation 1, this is our equation 2. Negative 12x gives us 0. 27y minus 7 minus 20y gives us 7y. And 24 and 48 is 72. So y equals 72 over 7. We plug this in. The first equation or the second, it doesn't matter. I'll go to the first. And we come out of that equation with the equation 4x plus 9 times 72 over 7 equals 8. Multiply both sides by 7. Giving us 28x plus 600 and 3/8. What I thought first, but somehow I was questioning myself, equals 56. And we solve for x. Okay, x is going to be negative 592 over 28. You can reduce that fraction a little bit. So it'll be a fraction. You plug that into whatever this is, plug that into the second equation. Well, you've got y and you've got x. You take y and x, plug them into this equation to check. That's process. Get open math will show you the same thing. And that should jog your memory. Something you did in the chapter on linear equations. If you did it in the chapter on linear equations, I'm not sure that every section did. It's part of the study of linear equations. So if it's new to you, it's still not difficult. You got to learn to do it. Okay.